Would you like to get away from using static credentials for your GitHub Actions and Terraform workflow? Well, that is what we're going to look at today with GitHub Actions and OIDC authentication. What's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday. Glad that you're here today. We're going to look at how you can integrate OIDC authentication from GitHub Actions over to Azure Active Directory, and then leverage that in your Terraform code to create resources in Azure and store your state data in Azure. It's pretty cool stuff. Before we get into that, two quick things I want to mention. The first one, HashiConf Global is coming up in early October. If you haven't already signed up, there's a virtual option and then there's an in-person option. I'd recommend in person if you can swing it, but if not, that's cool. If you do happen to come in person, I'm going to have two possible things that you could get from me. One is this adorable little Terraform taco, and the other one is it's a Vault burrito. So if you do happen to be there, find me, ask me about one of these, and if I still have any left, I'll give you one. No problem. All right, the other thing I want to mention is that there is currently, until the end of the year, a program going on with Pluralsight called Cloud Happy. And with Cloud Happy, if you sign up, it's free. You will get access to my Terraform courses on Pluralsight to prepare you for the Terraform Associate Certification. So if you like free stuff and you want to get your Terraform cert or just learn more about Terraform, hey, free training for you. I'll include a link down in the description. Now let's dig into OIDC and why you might want to use it with your GitHub Actions. To best explain why you want to use OIDC with your GitHub Actions, it probably makes sense to understand where you probably are today and some of the shortcomings of where you are. Now, if you just want to go straight to the technical bits, check out the chapters that I have for the video. You can jump straight to that part. But if you're more curious about the justification or the theory, let's dig into that for a moment. Now, I'm not going to explain all about OIDC because that would be a whole series of videos all on its own. Suffice to say, OpenID Connect, or OIDC, is the mechanism that we're using to do this authentication from GitHub Actions to Azure AD. Now let's think about what you probably do today if you're using GitHub Actions to deploy stuff using Terraform to any of the major clouds. You probably have the credentials that are required for those baked into your secrets associated with the repository or with the environments in your repository. And those credentials are going to be static. It's going to be a service principal or an IAM user or whatever identity there is for the cloud you're using, including basically a username and password. Now, the problem with that is there's a few things, right? One, it's static credentials. If they get leaked, somebody else can use those, and they're long-lived, so they can just keep using them until you either realize or you roll the password. Now, if you decide to roll the password or credentials for that action, now you need to update it anywhere that credential is used, and oftentimes you end up using the same credentials in multiple places because getting new credentials provisioned can be a huge pain. So now we have a long-lived static credential that can be abused by others. It's not a great look. What you'd probably rather have is a credential that is dynamically created each time you need to run the action and then has a very short lifetime that expires after that action is completed. That sounds like pretty useful, right? That is exactly what this OIDC authentication is meant to do. So that's the high-level theory of why you'd want to use it. Let's dig into some of the details and talk about the actual workflow that happens with GitHub Actions as it talks to Azure AD. And this is going to be broadly applicable to any of the major public clouds and other services that support OIDC. Now that we understand why you might want to use OIDC, let's talk about the actual workflow of how OIDC is leveraged by GitHub Actions. It all starts with a token, and the token is going to be the thing that allows for this authentication flow. The GitHub Actions has access to a GitHub token service, and those tokens will be issued to the runner that's executing your workflow. Now, that runner could be a hosted runner managed by GitHub or a self-hosted runner that you've spun up yourself. That part doesn't matter so much. It just needs to be able to reach out to the service and get a new token. Now, what's in that token? Well, the token's going to have a few key properties in it. One, it's going to have information about the issuer, the service that issued that token, and that will be cryptographically signed. Then it's also going to have information about the intended audience. Who is, or what service is this runner going to be presenting that token to? And then lastly, it's going to have a subject, and that subject provides information about the runner itself. And this is going to be specific to the repository associated with the workflow that runner is executing. And it will include details like the repository itself, what's the name of the repository, if there's a particular branch or reference, if there's a tag, if this is a pull request, or if it's an environment. So that is going to form the subject of the token. The runner is going to take that token and send that token to Azure Active Directory along with a service principal set of information. That's going to be the tenant ID for Azure AD and the service principal object ID. And it's going to request an Azure Active Directory token it can use to do things in an Azure subscription. On the Azure Active Directory side, it grabs the token, it takes a look at the issuer, and it looks for a federated credential in its settings that matches that service principal, tenant ID, and the subject that's inside the token. If all of those things line up, then it's going to validate that token against the GitHub service that issued that token. And as long as the token is valid, it will now issue a temporary token for access to Azure that is going to have a relatively short lifetime. And we're talking minutes or an hour, not multiple days, right? So now we have a dynamic credential that was generated specific to the repository and potentially a branch tag or environment in that repository, and it has a very short lifetime, and you don't have to manually manage these passwords for your various service principals. That sounds pretty cool. So now let's dig into the specifics of how you would configure the Azure Active Directory side, how you would configure the GitHub Actions side, and the actual workflow inside the GitHub Actions that will use this JOT token. Oh, by the way, the token, it's called a JOT, and I'll get into that in a little bit. To take advantage of OIDC with GitHub Actions, we have to do some work over on the Azure Active Directory side. So let's jump over to the portal and take a look at what we have to configure on the Azure Active Directory side to get things prepared for our GitHub Actions. Okay, here we are in the Azure Active Directory portal, and I am under app registrations. And I know I said service principal earlier. Here's the thing, in the portal, if you're looking for the service principals, you'll actually find them under app registrations, which I know sounds kind of weird. It's just the way that Azure Active Directory was structured. But trust me, the things that we're seeing are applications that have service principals associated with them. Now, the service principal we're interested in here is OIDC simple 86962, which is like a random ID that I tacked on to the end. So let's take a look at that. We'll click in there. And this object is made up of an Azure AD application and then a service principal that's associated with that application, which is why there's so many different IDs. And if you're curious about the differences between all the different IDs and numbers, I actually have a blog post I'll link down in the description that demystifies Azure AD service principals and applications. But the thing that we're interested in is in certificates and secrets. And there's 3 tabs here. The one that we care about is federated credentials. And this is where the special sauce comes in. This is how it can evaluate the subject of a token. So let's take a look at the settings for one of them. In here, it knows the scenario that we're dealing with, which is GitHub Actions deploying Azure resources. So it's going to customize the fields you'll see here specific to that particular scenario. But there are other scenarios supported, including Kubernetes accessing Azure resources or a generic issuer where you can just fill in the fields how you need to. Now for this one, it pre-fills in the issuer because it knows the URL of the GitHub Actions token service. So it just fills that in for you. You can edit that if you need to, but I can't think of a scenario where you might want to. And then you have to fill out the organization or the user of the repository that's going to be making that request, the name of the repository, and then you have some options for entity type. Remember, we're trying to build a subject identifier string. So you can select branch, environment, pull request, or tag. And yes, pull request is different than branch. So if you have a push to a branch, that will show up as a branch subject identifier. If it's a pull request against a branch, that will actually show up differently. So we'll see that in a moment. Below that, because I've selected branch, I've told it which branch it should be looking for in the subject identifier. And then based off of those settings, it builds the subject identifier for you, giving the repository and then the reference in here, which in this case is heads main. Okay. And then down here below, there's just some credential details, including the audience. And I would recommend not changing the audience. Again, that's pre-filled in for you because the action we're going to use in GitHub Actions, Azure Login, uses this audience by default. You can customize this, but again, I'm not sure why you would. So this is the credential associated with this service principal. You'll note there are two credentials in here. There's also one for pull requests because I want to use this service principal for both. But I could have two separate service principals, one that's for pull requests, and that might not have permissions to alter anything in my Azure subscriptions, and then a totally separate service principal that's for pushes that actually do change things in my Azure subscriptions. For the pull request credential, you'll note that the entity type here is pull request, and so the subject identifier is a little bit different. Okay, now that we've seen all of that, I'll go ahead and cancel out. If you want to create these, but you don't want to go through the portal, hey, I wrote a Terraform module that's available on the registry, and it's called Terraform Azure AD GitHub OIDC, and it will create an Azure Active Directory application. It will also create the service principal and the federated credential all for you, so you don't have to do that yourself. If you're looking for that, I've included a link down in the description to the entry on the registry. Okay, so that's everything you need to do on the Azure Active Directory side for the federated credential. The other thing that you need to do is then grant that service principal permissions on the subscriptions that you want it to create resources for. Now I've already done that. We don't need to go through that. That's pretty straightforward. Let's jump over to GitHub Actions and see how we configure GitHub for all of this. Okay, over in the GitHub repository, it's called GitHub Simple OIDC Testing. And if you want to follow along, you'll have to fork this repository. In this repository, I have some GitHub Actions workflows defined, and I also have to define some other things. Most importantly, I have to define some secrets that the workflows will use. So let's go over to settings first and take a look at the secrets that are in here. So I'll look at the actions for GitHub secrets, scroll down, and I have a few different secrets here. And the ones that I want to call your attention to, because these are required by the action we'll use in our workflow, are Azure Client ID. That's the client ID of the service principal we just saw in Azure Active Directory. Azure Tenant ID, which is the Azure AD tenant where that service principal exists. And then optionally, you can include Azure Subscription ID, which it uses to confirm access to Azure. Now, there is an option you can specify no subscription if you would like to, but since we are using an Azure subscription and making things, I figured I would just keep it in. The other three arguments are specific to the fact that because I can use OIDC authentication to create resources, I can also use it to store my state data. So I've created a storage account with a container where I'm storing the state data for this configuration. So I'm using the authentication for both. Hey, that's pretty convenient. Okay, that's what you have to set up in terms of secrets that will be leveraged by your workflow. Now let's take a look at the actual workflow itself. So I'll go back to code here, and workflows are always stored in GitHub/workflows. So we'll go to that. And I love the commit message. I had a little naming issue and I wasn't happy with myself. So anyway, I have two workflows in here. One for when a pull request comes in to the main branch, and another one for when a push is made to that main branch, which if you're thinking about a typical Terraform workflow, you would create a feature branch for a change, then a pull request to merge it to main, and that would kick off the first workflow, and then you would merge that change, which would be a push to main, which would kick off the second workflow. So let's look at the pull request one first. In the pull request, under when this kicks off, it says on pull request branches main. So we can see a pull request that targets main is going to trigger this workflow. Now, under permissions, you have to give it very specific permissions for it to be able to get that token from the token service. And the permission you need to give is ID-token write. Now, why is it write and not read? I'm not sure. I think it's because it's technically sending a post request to the token service, which could be considered a write. So it needs those write permissions to send the post and get the token. Check my homework on that, but that's my theory behind it. Regardless, you need to give it permissions ID token write, and that is something you have to explicitly set. The other thing is you're going to want to set contents to read, which allows it to read the contents of the repository. Now, my workflow also puts a comment into the pull request, so it needs write access to issues and pull requests as well. Now, what's actually happening in this process? Let's go through the steps that the job runs. The first step is to check out the repository. That's standard for most GitHub actions. I need the repository information. The next one is to install Terraform. I'm going to be using Terraform after all. And then the third one, this is very important, is logging into Azure with OIDC, and we're going to use the Azure login GitHub action to do that. Now, there's a bunch of different ways you can log into Azure, and OIDC is just one of those. But based off of the arguments we're specifying here, it picks up on the fact we want to use OIDC. We're specifying the client ID, which it gets from our GitHub secrets, with the tenant ID, also from secrets, and the subscription ID. Now, you can put an option in here to skip the subscription ID, but I kept it in here. Based off of those with arguments, it deduces, oh, you want to do OIDC authentication, and goes through the workflow for you. So that's all you have to do in your GitHub actions to take advantage of it. It's pretty simple. And then there's a step after that that just confirms that the AZ CLI actions are working by running an AZ account show. Then we get into the actual Terraform stuff, which is initializing Terraform. And remember, we're storing our state data in a storage account on Azure. So as part of the Terraform initialization, I'm passing it a backend configuration targeting the storage account, container name, and resource group name. But what's nice is I'm using that same OIDC authentication to access the storage account, so I'm already authenticated to access it. That is super convenient. All right, and then the rest of it is standard. I'm doing a format check on the Terraform formatting. I'm doing a validation of the code just to make sure that it's syntactically and logically valid, and then running a Terraform plan to see what changes would occur, and writing those changes out to a comment in the pull request. That's everything that's in the PR. Now, let's take a look at the code itself, just so you can understand what's happening from an authentication standpoint, especially with state data. So if we go and look in the terraform.tf, I have a block here for the Azure RM backend. I have the key hard-coded, which is fine. I also tell it that it's using OIDC authentication, and I'm using Azure AD authentication. If you want to know more about that, I have a whole blog post about it, but the key here is that I'm telling it to use OIDC for the backend, so it knows to look for those credentials and use them. Okay, so that's everything that's in the pull request workflow and the backend configuration. What does this configuration actually do? It just creates a resource group. That's it. Very, very simple and straightforward. But you'll note in the Azure RM provider, I have use OIDC set to true. You can also do that through an environment variable, but I have it hard-coded in here. So either one will work for that as well. Okay, so let's actually go through the process of running this and see what happens. Now, in order to do that, what I'm going to do is create a new branch. So let's go over to Visual Studio Code. And I am going to go back to the main branch and just do a quick pull to pull the latest changes. And now we're going to create a new feature branch. And I'll call that feature branch today's date. So do that, create new branch. Okay, now we're on a new branch. And I'm going to make a simple change here to the default value for the resource group. So I'll just change it to today's date. And then once that is done, I'll say change date and commit it. and we'll push that up to the repository. So I've published this branch. Let's go back to the repository and create a pull request based off of that feature branch change. All right, my change has been pushed up. I'll click on compare and pull request, and I'll just go ahead and click on create pull request. Well, I have to give it a title first, huh? So we'll call this change date as well and create the pull request. Okay, now that the pull request is created, that's going to kick off a workflow in a moment. So there we go. It has kicked off the GitHub Actions workflow. Let's go into details and see how it's actually running. So it's setting up the job now. Now, once it goes through the process, we'll be able to see the actual Azure login action and what happens with that, and then how it successfully runs that Azure CLI command, and then it's able to do the proper Terraform initialization. So let me just scroll back up for a second. Actually, let's wait for a second for the whole thing to finish, and then we can walk through it. So let's jump to that now. Okay, the action has completed successfully. You didn't much have to watch the whole thing, right? Let's just expand a few of these. So the Azure CLI login, you can see based off the fact that we specified the right arguments, it figures out I'm using OIDC authentication. And it also tells me what the issuer is and the subject claim. So if I'm trying to do some troubleshooting here, it's showing me the claim here, and I can make sure that federated credential exists over an Azure Active Directory. If you're getting an error that the federated credential doesn't exist, you can check it against the subject claim here and go, oh, well, I see why. Then it ran the AZ command to show my account, and it does hide some of the private information here with the 3 stars, so you don't get to see my tenant ID and whatnot. And then it went through the standard Terraform initialization, which it was able to do successfully because it's using OIDC authentication. And then it ran through format and validate all that jazz, ran a Terraform plan, and then added that as a plan comment. So if we go back to the pull request and take a look down in the comments, it's added a comment in here with the plan of what is going to change. So I can click on show plan, and it will tell me, hey, I am replacing your resource group because you changed the name of the resource group. Now, let's say I'm fine with that. I'll go ahead and merge that pull request, and merging that pull request is going to kick off the next GitHub action. So let's go ahead and take a look at that action real quick. Yeah, let's actually just go into the action and see what it's doing, because what I want to point out about this action is that the subject issuer is going to be different because this is a push to the branch as opposed to a pull request. So you have to make sure that you have both federated credentials for that service principal in your configuration. So scrolling back up here, we can see the subject claim in here is slightly different. It's the name of the repository, and then ref:refs heads main. So making sure that that exists as a federated credential in your service principal is going to be kind of important as well. So you want to make sure you have all of the federated credentials that are going to be used by that service principal. So if you're going to be using it for multiple branches, you're going to have to add an entry for each branch because it doesn't support wildcards or anything like that, which is unfortunate, but maybe good. I don't know. I'm not sure. But based off of this, you can see I am dynamically generating these credentials using OIDC, and then these credentials are only good for a short period of time, and then poof, they're gone. So I still have to manage a service principal, but now I don't have to manage the credentials or a password or a secret that that service principal is leveraging in my workflow. That's pretty cool stuff. Now, if you want to follow along at home and try this out for yourself, of course I wrote up a Terraform configuration to help you out with this. And just like all my other stuff, it's stored in the Terraform Tuesdays repository. The folder you're looking for is 2022-09-27 GitHub OIDC. I have 2 setups in here. One is a much more complicated setup that uses 3 different environments and lets you walk through all the environments and use different credentials and different Azure subscriptions. You can do that one if you want. The one that I showed is the simple setup where it's a single repository, single Azure subscription. So if you do want to use that one, I've included a README with the files so you can walk through that README and set it up yourself. This is the README here. It'll just walk you through what you need to have already set up, and then go ahead and deploy out the configuration, it will require you to fork that simple OIDC example repository and then get a GitHub personal access token in order to configure the secrets on there, because it's going to take care of that for you. So if we look at what's in the main here, I use the module that I developed to create the first federated credential, and then I add a second federated credential for the pull request, and then creating the contributor access to the Azure subscription that currently exists, as well as creating a storage account in that subscription for the state data that we're going to be storing in Azure RM. And then down at the bottom, we have the creation of our GitHub secrets in the repository. So you're going to be using Terraform to add those secrets dynamically, so you don't have to enter those in yourself. So if that's of interest to you, jump over to the Terraform Tuesday repository and check it out, and you can follow along and get GitHub Actions working in one of your repositories. It's pretty cool. Hopefully in the demonstration, you see how useful OIDC is. And I want to point out that this is not just for GitHub Actions and Azure AD. GitHub Actions supports AWS, GCP, Azure, and HashiCorp Vault, as well as sort of generic targets, as long as you can configure that generic target appropriately. OIDC and the tokens it issues, those JSON web tokens, or JWTs, I told you I'd get back to that. They're called JWTs, which, whatever. Those are becoming the future of authentication and dynamic credentials. So I definitely recommend digging into them and just getting a better appreciation and understanding for them, because they really do allow you to create a dynamic credential with limited permissions and a limited lifetime from a trusted chain. And that is huge. That's going to do it for today for Terraform Tuesday. Thank you so much for watching. I just want to remind you that the Pluralsight Cloud Happy campaign is happening for the rest of 2022. You can sign up for free and take all of my most of my Terraform courses for free, and also try to get your Terraform certification. So if that's the kind of thing you're into, definitely check it out. I also want to mention that I have a new podcast called Chaos Lever with my buddy Chris. If that's of interest to you, you want to hear a little more from me, we cover a range of different topics in the technology ecosystem, and we also have a lot of fun doing it. So you can check that out at chaoslever.com. Thanks again for watching. Stay healthy, stay safe out there. Bye for now. You might have been wondering what's on my shirt this whole time. I hope it wasn't too distracting, but yes, it is in fact a T-Rex inside of a taco with some sort of cocktail. I saw this shirt and I was like, I gotta have it. So now I have it. And if you find me at HashiConf Global, I'll probably be wearing it on one of the days. So definitely check that out too. Bye.